Hi, Dr. Engstrom.
Okay, so we've been learning about types of rocks, correct?
Yes.
Okay, so I would like us to start our lesson with our title, types of rocks, and then today's date in our science notebooks, which we already have out. We got our pencils out, we're ready to go. While we're writing our title, I'm going to go over a few expectations. This is a hands-on activity that we're going to be doing today. You're also going to be working in smaller groups at some point. So I need us to be working together, encouraging each other, and having a positive attitude. And also remember that we're keeping track of our stars. We got each row, each of us have a star. Group 5 is in the lead right now. How do we get stars? Who can remember how we get them? Alexa?
You follow direction and you always do the right thing.
Yes, you can get a star that way, but there's also other ways to get a star. How else can we get a star? Nevaeh.
You can get a star by answering the question or trying.
Answering the question or trying. That's what she says. So I'm going to start off by giving her a star. Okay, and what does she mean? And I want someone from group 4, because I haven't heard this yet, but what does she mean by trying? Max?
She means trying out the question even if you're not sure that you have the right answer.
And how can you try, even though you don't know the right answer?
By trying to show your work and trying to figure it out on paper.
Exactly. And do we care if the answer is wrong?
No.
We care more about your effort, what you're putting in. Okay? As long as you're trying your hardest, because we can always learn from our mistakes. Okay? So the first thing we're going to do is we're going to be talking about types of rocks. So the first type of rock that we're going to be talking about is igneous rock. What do we know about igneous rocks?
Oh.
What do we know about igneous rocks? We'll give group 4 a chance again. Yingwell?
Igneous rocks are rocks that are given the name from Latin root word fire.
Yeah, we discussed that yesterday. And I remember Yingwell even specifically answering that question yesterday, so he remembers it. Why is it called fire? Why is it from the root word fire? Where did they get that information from? Lazaro?
It got a word for fire because another type is ignite.
Ignite. But where does the rock come from? Alexa? I'm sorry. A volcano. So the magma or lava from a volcano comes out and it doesn't cool, and that's how we get its name, because of the fire from the lava or the magma. And it comes, so Latin root word fire, we talked about that, formed by volcanoes. When a volcano erupts, it spews out hot molten rock called magma or lava. If it's magma, it comes from the ground. If it's lava, it's from the, one's underwater and one's over water. But magma and lava both mean the same things. And I remember Denaya and Max asking about that yesterday, like what's the difference between lava and magma? They're both the same thing. I believe magma is underwater and lava is when it actually comes out of the volcano and hits the earth. Denaya, am I wrong? Magma is under the ground?
No, yes, and it keeps out from the volcano when all the pressure is built up and it eventually.
So one's underground, magma's underground. When it comes outside of the ground, that's when it comes to lava. But they're both the same thing. They're both coming from a volcano. Eventually, the magma will cool down and harden either when it reaches the Earth's surface or somewhere within the crust. This hardened magma or lava is called igneous rock. I have a special surprise today. Put your hands down, please. I have Ms. Kamel. She gave me each type of rock. I wasn't expecting this. but she really did, she came through. So what we're gonna do is we're gonna look at an igneous rock right now. You're going to be split off into groups based off of your row. So this will be the first group right here, JJ, Gerard, and Nevaeh. This will be group 2, group 3, group 4, and group 5. I'm going to assign each group a leader. Put your hands down, okay, for right now. Each group is a leader. So the person in the very front of the row will be the leader. So in this case, Nevaeh is the leader, Cintron is the leader, Miguel is the leader, Anderson is the leader, and Denaya is the leader, okay? So when I give you your igneous rocks, the first thing I'm going to have you do is count your rocks. Your group member, your group leader, I should say, is responsible for the rocks, okay? Who's responsible?
The group leader.
The group leader is responsible for the rocks, okay? So each rock has a number. On the bag is the number of rocks that are inside the bag. So before you even open the bag, you're going to count how many rocks are in the bag, okay? If it says it's 8, it has to be 8 in the bag. And if it's not, that's when you raise your hand and you say, Ms. Schmidt, I don't know why, but there's only 7 rocks in this bag, okay? And then we will discuss the rocks from there, and then we can open it. So we're going to give each group a tray. In the tray has your rocks. It has 2 liquid glue sticks, or liquid glue, which is not to be touched for right now, okay? Just stays in there. And then 1 pair of gloves. The person that gets the gloves is going to be the team leader, okay? And they're the ones that are going to be in charge of using the glue and touching the rocks, okay? Because of COVID, not everybody can touch it, but we can all make observations and we can all understand what these rocks are. Because I think it's very important that we are able to actually see the rocks. Dingwall?
So magma and lava are the same thing, but they come from different places.
They both come from volcanoes, but they are the same thing. One just is underground. Like did you know that volcanoes form underground?
Yes.
Yes, they do. And some of them never come above ground. They actually stay in the ocean, deep in the ocean. So if they never come out of the ground, but it still erupts, it can still erupt. And so that might cool down at the bottom of the Earth's surface. So you might have those rocks underneath the ocean. You also might just, I don't know where else. I can't really go on and on about it, but do you understand? One is cooled off underneath the ground, and one erupts from the Earth's surface.
So the lava comes from underground?
It comes from, like Denaya was saying, it comes from the Earth's crust, from the, can you explain what further?
So the magma is like the liquid rock under the surface of the earth, and then the magma can all that pressure under there, and then eventually the magma will erupt from the volcano. And then
So where does the magma and the lava come from?
it comes from under the underground. It comes from under the earth's surface.
Good job. Yes, it comes from underneath the Earth's surface from the Earth's heat. Okay. So I'm going to give each group. Ms. Montes, did you want to help me distribute the groups? You're going to have to, I'm going to put your guys' group over here, and we'll put it on the ground here. You guys can work over here, because you're going to have a lot going on over there, okay? So I'm going to give row 5 a star and Yanuel a star, because Yanuel asked a really good question, and Denaya helped him out and answered the question. And we can research volcanoes if you want to learn more about volcanoes at a different time, okay? Yes, Denaya?
I have a question.
Huh?
Why do they have to change the name of magma when it comes from out of a volcano?
Why do we have to change the name?
From
It's to differentiate the difference between the magma and the lava, because one of the magma comes from when it cools off underground, and the lava is really hot. It comes from above ground. So one's below ground and one's above ground, and it's to differentiate the difference. So it's like if I just said magma, I know, it never reached the Earth's surface. If I said lava, I can physically imagine lava coming out of a volcano, right? Coming down the sides of it. Okay. So who can tell me before we go into this, what we should do when we go to our groups? Okay. What should we do, Gerard?
You have to wait till the leader put on their load.
Mhm.
Or do you have to wait until you put on
So we now understand that the leader gets the gloves. What is the first thing that the leader should be doing? I want a group leader to tell me this. Miguel? What should the group leader be doing first? What's the first thing you're going to do? Counting the rocks. That's exactly right. So I have 1 and 3. 1 and 3. So they're going to count the rocks. We're going to find out. And then once I give you the go ahead, we can open up our rocks and we're going to make our observations. When you open up your rocks, I want you to think about, what do they look like? What do you notice about the rock? What makes this rock unique? Okay? We understand now, we know about igneous rocks, sedimentary rocks, and metamorphic rocks. Thank you. We know a little bit about each type of rocks. So now we can ask ourselves, what's the difference between this rock and maybe a metamorphic rock or a sedimentary rock? I want us to be making some observations while we do that. Do we understand? Okay. Yes.
Where did lava even come from? Because
Inside the Earth's crust. We'll explain. Maybe we'll do a whole separate lesson on lava and magma because that's a little off the track from what we're doing right now. Okay.
whoa,
Oopsies, I didn't mean to do that, but.
powdered.
But okay, so let's meet with our groups, and I'm gonna put 2 minutes on the clock, or maybe 10 seconds. And when I hear all the groups are ready and that they've counted their rocks and the number of rocks is in the bag, then we can observe it. I'll put 2 minutes on the clock, and we can make some observations of the rocks. Okay, so go to your groups now. If you want to take your science notebooks and write down your observations, I would really encourage that. Okay, so I already caught someone. 1, 2, 3. Let's freeze for 1 second. Thank you all for having your eyes open. I see some people have their gloves on, but I noticed that one team already has their rocks out and onto the thing. And that, what was the first thing that we were supposed to do?
Count our
Count this. So we're not opening the bag until we know how many rocks are in each bag. Please count your rocks, okay?
I'm not sure if I put 2 of them. We have 10.
You have 10? You have 10?
No, we have 9.
You have 9. Maya, 2, 4, 6, 8, 10. Okay, so your group can go ahead. Your group can go ahead. Remember that we are making what? What are we doing with these rocks? We're making observations. What do you notice about these rocks? What do they have in common? What do they have different? You got 10? Okay, I'm going to put 2 minutes on the clock. Okay, I have 2 minutes. Go ahead and make some observations. What do you find when you've noticed about the rocks? Janaya is asking herself, what kind of rock might it be? We all remembered how to identify some of our rocks, right? So maybe take a prediction, what might your rocks be?
Okay, we only it's not like some
Time's almost up. Make sure.
3, 2, 1.
Okay, 5, 4, 3, 2, and 1. If you guys wanted to use, like I see Jaden using the resources that he has given from him from Ms. Kamel from our lab, that is great. I wanted to know, like, what did you guys notice about the rocks? Does anybody have anything that they would like to share? Like maybe like one person from each group. Is that your?
This one right here kind of looks like coal, and how it kind of looks like coal and why it's because it has a darkish color and it's pretty rough.
Okay, so he sees the dark color, he sees that it's pretty rough, and he says it might be coal. So he noticed this. What do we call that about the rocks? We're looking at their color and we're looking at.
I think this one is.
Okay, so let's see here. King, you look like you're dying to tell me something about these rocks.
The black rocks look like broken glass.
The black rocks look like broken glass, he says. And that is true because igneous rocks are cooled off. My group over here, we need to stay quiet. 5, 4, 3, 2, 1. King's group, one for a second. Please give them a star. I forget which, 1, 2, 3. First off, they use their science notebook to write down all of their observations, which I encourage and love. And then he noticed that this is very shiny, and it's shiny because the thing about igneous rocks is that they will cool down. And because of it cooling down and water being put on it, it actually made it very, very, very shiny, okay? Igneous rocks do not go under heat. They're not heated up. So that is interesting about it, that it's shiny. I want you to pay attention to this because maybe when we go into, what was the third type of rock? The metamorphic rock, thank you for your help. They might not be as shiny, right? Because they go through heat. So we're going to find out if that is true or if that is not true. So let's pay attention to that. What did your group notice?
You notice that some type of rocks are.
Hold on, you notice that they're all different colors. And is that okay? Why do you think they're different colors? Yes. And I remember Janaya was looking at me when I said this because I meant to say that they don't go through pressure and not heat, right? Is that what you were trying to say?
No, when you learn how to fill out the next one, you have to put those two together to get metamorphic.
Oh, okay. So I think that we'll focus on the difference between igneous and metamorphic, and then we're going to be working with sedimentary. So perfect. And why does it come from different colors? What was? He thinks through time they change. What about other things that might change? What else might change? Be different. What about these different rocks? What about where they came from? Do you think they all came from the same location? No, probably not. So that's interesting. What did your guys' group?
We found out that this one we know this one is pumice, and we think this one is hematite.
Okay, so they noticed that they think that they have pumice in their bag, which would be correct. And this Matos, when you guys were working, I'll come around and show you some pumice because Ms. Kamel showed me today that the most interesting thing about pumice is that it's the only rock that can float. So she said, show them that Okay, thank you. At least more is better than nothing else. Wait, Anderson, you have 8. You have 8. Remember, we're paying this time the number is 8. Please ask. Okay, and what are we doing when we're looking at these rocks? Who can raise their hand for their group and ask and say what we're doing for these rocks? Stephanie? We're doing what? We're counting them? Yes? So did we all get the okay? Do you have 8 rocks?
Yes.
And then what are we doing, Zaire?
How many?
Zaire bonus gets 1 too. He said we're going to observe them using those scientific terms. Observe. Good job. Appreciate your paying attention. You have like hair on the side somehow. I think it's my hair.
How many?
8.
Centron, you ready? Perfect.
This looks like
Yeah, it looks like flint.
Naya, how many?
I'll check what's in there. Oh, so he did a streak test. What do we use streak tests for? Do we use them for rocks and minerals or just rocks?
Rocks and minerals.
Rocks and minerals.
Ready?
Anderson, are you the so I mean, you're way behind
What property is that? Well, cleavage is when it breaks and it makes a pattern, right? But if it breaks easily, oh, I guess hardness. Hardness is based off of scratch, right? So yeah, you're right. It would be that. Yes. And now we're talking about minerals. What do we notice about these? What do we notice about the patterns? What do we notice about the colors? The size. So did you try to identify any of the rocks? 1 more minute with your groups. Sorry. You didn't find it? I will tell you what they are. Does anybody have one that looks like the one in my PowerPoint? And have like a pattern like that. What is the same? What's similar? What's different? Okay, 5, 4, 2, 1. Okay, I do love that we're working together. Okay, sometimes when we work, it's nice when we work together, right? We're having fun. And I like that when we are talking to each other, we are helping each other, especially in this group right here, group 4. You guys really, really helped each other identify some of the rocks. Did we figure out what any of them are?
Yeah.
Yes. Which one?
These black ones are unpolished hematite.
Unpolished hematite.
Yeah.
These ones are moss
Agate.
and this looks like it's a granite.
Yeah, it looks like granite. That one that you're picking up, I think, is marble. There's a marble in your one. Everybody pick up
That's Thomas, that's Thomas. This one?
the white one. Everybody hold up the white one. Hold up the white rock, group leaders. This white one is marble. Okay, when I think of marble, I think of marble countertops. Have you ever gone to see countertops that are really, really nice and white and clean? Those might be marble countertops. You see these maybe in your everyday life.
It looks like.
Did you get a star? Yeah, actually, I'm gonna give everybody a star because everybody is working
I got it.
very well. Thank you, Ms. Montes. And then I have one last question. I have a PowerPoint up here of the metamorphic rocks. Metamorphic rocks are formed by great heat and pressure. Remember we talked about that. That pressure. Everybody do this when I think of pressure. I always think pressure. Pressure. We can kind of say it. Okay, that's enough. And then we say it kind of fun because it's a fun thing to do. Heat and pressure. Both igneous rocks and metamorphic rocks go through heat, but one of them gets a lot of pressure and the other one doesn't. And do we notice the difference here? That we see a lot. My groups notice matches this rock up here. Which one do you think matches? What do they have in common? I want someone that hasn't spoken yet. Maybe JJ? What do they have in common? What does it look like to you? It looks like a piece of wood. Interesting. What do you notice about the texture of it? It's hard. Both of them are hard. Take someone in this group to help you to answer what they think is similar. 1, 2, 3. What do they have in common?
What they have in common is that if you grab the rock and you look at that rock there, they look the same because they both have gray stripes and ours has gray stripes.
Stripes. What does he mean by stripes? Good job, Lazaro. What does he mean by stripes? Alex, what do you think he means by stripes?
Means by stripes on the rock.
Stripes on the rock. And where do you think those come from? Stripes on the rock. So you're thinking like, my group over here, let's pay attention. So you're thinking like right here looks like a stripe, like here looks like a stripe, right here looks like a stripe, right here looks like a stripe. What do you think those are called? What can we call those things? Alex, try again, yeah.
One's the one that changes shape and water gets on it. And one gets squished.
Maybe, but what do we call that when you have things going on top of another, on top of another?
Layers.
Go ahead, Alex. Alex, go ahead.
Covered?
No, not covered. My friends in Read 180 should know this, so I'm going to pick someone that's in Read 180. Zaire?
I think what it is. Wait, what's the question?
When you're stacking things on top of each other.
Oh,
What do we call that? What's one word that we call that?
we call that layers.
We call that layers. Were you going to say that, Hezekiah?
Yeah.
Good. I'm glad that we can inform. So perfect. Okay, I want my team leaders to put the rocks back into the bag. Make sure you have as many as you have, and then you're going to pick up a new bag. Miguel, go on the other side of that table, please. Yes. I have to walk this way. Come on.
What's the reason why it has
I just saw that.
Where's your tray? Tray. I need the tray. Thank you, Ms. Montes, for your help. You know, Max, I don't necessarily know a whole lot about wood like that, but I can find out right now. So these are our sedimentary rocks. Do you have as many as an 8? You counted. My group, you counted before you jumped in on.
How many?
We got 8.
I didn't prove it. Did they count, guys?
We got it.
Okay. You have 9. So, okay, we were supposed to have 1 gray one, shale.
How many?
She has 9. So, yeah. 1 limestone, which is beige. 2 sandstones. 3 sandstones that are red. 3 red ones. So you got 4 red ones. Okay, so I'll just make a note that we have 4 red ones in here. Okay, but that's fine. I want us to notice, feel the rocks. I really want us to touch them and feel them. Oh, okay. This is the group. The group leader can touch them and tell me, is there any dirt on it?
She was talking about
It's COVID. We can't all touch them, right? Okay, I'm gonna put 1 on the rock. Every single one of these is sedimentary, guys. Every single one. There's not one in here that's not sedimentary. They look very similar, don't they? So what would be the difference? We had one that looks like kind of like marble too, right? This one's look, when I pick it up, we're not supposed to all touch this, but what I pick up, let me see on my fingers. 5, 4, 3, 2, and 1. I want my group leaders to look at their gloves. Are your gloves a little dusty?
Yeah.
Why? Who can tell me why do you think that it is dusty? Anderson, thank you.
I think they're dusty because all of the small particles that form it.
Wow, look at that big word. Particles, he said. All the small particles. What about the small particles?
In the rocks that when we touch them, they get on us because the gloves might be like a surface, soft surface.
Perfect. So he says that the particles, it might be on them because it's a soft surface, and that there's particles. I know that sedimentary rocks are formed by years and years of compacted together and being hard. Because of that pressure, everybody go pressure, and times, it creates all this stuff. But then we have sedimentary rocks where it comes, all this sediment, all of this dirt is coming from, so it's going on the rocks. Okay, because a lot of these things we can find sedimentary rocks by just going outside. So a lot of the outside world, the outside elements are on these rocks as well. Okay. Another thing that's interesting about sedimentary rocks is that they often take on the appearance of the sediment themselves. So I have a picture. It goes back. It's not going to let me go back. I'm going to come to the computer. Don't worry. So we have a picture of a sedimentary rock. Let's make sure that we can all see this. My group over here, make sure that you guys can see my picture. And I asked like 3 different people what this picture reminds us of. Some people said, what do you guys think it reminds me of? Kim, you want to tell me what do you think this picture is? What kind of landscape is it? What kind of climate do you think?
I think it looks like red sand and white.
Red sand and white. I want you to look to your groups and discuss what you think this image here is of. Oh, why do I keep doing that? It looks, so I hear, what does it look like? Does it, discuss with your groups, look at your group, huddle up, come on. Sorry, it looks like Whoville? Well, I can guarantee you it's not Whoville, it's definitely not Whoville. Okay, let's see if we all have different answers. 5, 4, 3, 2, and 1. See, our group leaders, I want you to tell me what your group decided was what they think this picture is of. Tanaya? The Grand Canyon? Anderson?
It looks like a desert.
It looks like a desert to you.
What?
Miguel? The Grand Canyon? He went with the Grand Canyon as well? Cintron? He said Grand Canyon as well.
We have 2.
Okay, what do you think it could be?
Dr. Like what did the Dr. Seuss come in?
Well, it's definitely not, okay?
Like, you know how he always has like the
Yes. We gotta keep going. What else do you think it could be?
And the Grand Canyon.
You said the Grand Canyon. My boyfriend, I showed him this the other day, and he said it looks like a lake that dried up, maybe, which is kind of like what the canyon is, so the Grand Canyon. I said it looked like the desert. I said it looks like some desert mountain that kind of hardened over time, maybe. So we could have all different things. But what do we notice about the rock? Does the rock look similar to the picture that I showed you?
Yeah.
What about it looks similar? What about it looks the same? How are they the same? Hezekiah? They have the same streaks. That's exactly right, because sedimentary rocks take on what it could look like. That's how we can find fossils in them, because they take on the shape that they have. So he notices that they have the same streaks as in the picture, and I agree with that. We have to move on. We have to move on. I'm very sorry. It is time to put your it is time to put your rocks into a bag and bring them to me, making sure that you have all 8 of them. Your team leader, make sure that you bring your tray with you as well. Zanaya,
I need to put a rock.
we can do this while we do.
Bring your rock.
Good. I think you guys might know more about rocks than I do. Which is a
Please
good
bring the
sign.
rock with the tray. That
Okay, I gotta
tray.
see, look, I gotta see.
White tray. White tray.
It looks like a metamorphic rock. And some of them look similar, right?
The train.
Huh?
The train.
Just to make sure.
How many?
Yes. Stay with your group. Stay with your group. Go with your group.
How many?
Oh, okay. So you might think it's late too. Okay, I want you to report back to your desks in 5, 4, 3, 2, 1. Okay, you can keep your tray. Okay, for today's activity, we are going to be making sedimentary rocks. They're found in many places. Just like I said, some of us said it looks like a desert, it looks like an ocean, it looks like all of these things. Sedimentary rocks are found in all of those places. They're even found underground in the ocean. Okay, in the deep, deep ocean, they're also found. Okay? So, sediment. The word sediment, we hear that when we think of sedimentary, right? The word sediment. So, some of us know what sediment is, but it's a matter that settles to the bottom of a liquid. Have you guys ever had like pulpy orange juice? Pulp orange juice, okay? And then we shake it up. And what happens with the pulp? Who can raise their hand and tell me what happens with the pulp when we shake it up? Where is it? Is it all in the same spot? Is it everywhere? Every time you drink it, do you get a glass of pulp or a mouthful of pulp every time you get shaken up? Zaire?
I think what happens is it gets turned into a solid.
It gets turned into a solid when you shake it up?
Yeah.
Would we be able to drink orange juice if it turned into a solid?
No.
No, but that's a good observation. What let's go with Nevada.
It mixes around in the drink, making it more of a liquid.
Yes, and we call that a mixture. Okay, when you're combining two things and you're mixing them together, we have a mixture. So it kind of does have like a little mixture where the pulp is combined with all of that. And then what happens if you just put it on? I have my orange juice. I'm shaking it up. Okay, all the pulp is everywhere. I get it in every glass and I put it down on the table and I leave it there for like, I don't know, 30 seconds, a minute. What happens to all the pulp that's in the orange juice? I'm going to give a star to someone who can tell me. Ms. Matos is keeping the stars, so she will be able to do that. And let's see here. Let's give some. Oh, we have almost exactly the same amount. Let's see, Gerard. Say what? It doesn't turn into sand. When you drink orange juice, pulpy orange juice, and you let it sit there for a second, does it turn to sand? No. Jones? It turns into a liquid? So we just leave our orange juice on the counter. Some of us have orange juice for breakfast, right? They hand out orange juice. Does it ever turn, does it come as a liquid?
Yes.
Yeah, does it ever change form? Not really. What happens to that pulp that's in there, though? If we just leave it down there for a couple seconds, what happens to the pulp? King?
I think it turns into water.
Doesn't turn into water. Max?
I think it becomes it's like an all in one big area and it's like one big pile.
Oh, it comes in all one big pile. It sinks down. Go ahead and put your hands down. It does, it sinks down. Now my picture is kind of blurry, so we just have to work with what we have right now. But you can kind of see, where do we think the sediment is? Hezekiah?
Bottom.
The bottom. It's all right here, right? And how can we tell it's at the bottom? What's the difference between the top and the bottom? What's the difference between the top and the bottom, Manuel? Do they look the same?
No.
No, what's the difference?
Because the bottom is darker and the top is lighter.
Why do you think that is? I love that Manuel is taking his time to really think about this. And I see Nevaeh giving him a big thumbs up. That is how we encourage our friends to keep trying, to keep going. Brennan, did you have an idea? I saw you kind of have your hand up. Why do you think it's darker at the bottom than it is at the top?
Because I think the one reason drop in the bottom because there's no grease stuck on the top and mostly at the bottom.
And mostly at the bottom. So he says all of the pulp sunk down to the bottom, and it's there, correct? Good job, Brennan. Good job, Manuel. They get stars for their team. So together we came up with the correct answer. That's exactly right. And so when we remember sediment, sediment comes from all different locations. It comes from deserts. It comes from oceans. It comes from lakes. It comes from all of these places. And then the sediment from near the bottom of the ocean sinks down to the ground. That's why we have, when we walk on the beach, did you guys notice that the water kind of sits on the top, and then when you're rubbing your legs down there, you see all the dirt that kind of kicks up. And then when you're done walking, it sinks down to the bottom and it doesn't do that anymore, right? Because all that sediment, all that sand sunk down to the bottom. So that's where that word comes from, sediment. Now, predict, how does the sediment get there? So we know that sediment comes from all different areas, right? We saw sediment on our sedimentary rocks when we formed. It's the dirt. We see the sediment sinking down there. I just talked about an ocean. The ocean has the sand that comes from it. If you're thinking about the edge of the cliff, there's all those rocks on the side of the cliff, right? Those are all sedimentary rocks. How does that dirt, how does that all come together? Where does it come from? I want you to take out your notebooks and write where you think that sand, where do you think that sediment or dirt is coming from? Because it takes dirt, it takes a lot of pressure and time to create a sedimentary rock. Where does all this dirt come from? Is there a wrong answer here?
No.
What would be, as long as what am I looking for? Cintron? As long as you answer the question, right? You tried your best. So what we're doing is we're going back to our notebook. We're making a prediction. Where does sediment, how does the sediment get there? How many years does it take for a sedimentary rock to form? So we just have to have it quick. So let's get a couple minutes to think. Because this is not something that we can just think right away. Some think time. Write a good description of what your prediction should be, and a number. How many years does it take? I found a rock. Can't be good. You wrote the answer. Try to look at your grammar. If you're done writing, look at your grammar. Make sure you have full sentences. Read it back in your head. So we're making a prediction. What do you think? There's no wrong answer. You just gotta write what you think. Okay, use it where the types of the type was. Types of rocks, we're making predictions about rocks, rocks. I like how Gerard and Stephanie and Alexa and Hezekiah are letting me know that they are ready. We're giving other people some time to think about their answers. Okay, I would like Stephanie to share her answer. What did you say? Just go ahead and read. What do you think? Dirt comes. And how long did you say it takes? That is really good prediction, I think. Good job, Stephanie. So she said dirt comes from rocks because, and she gave me an answer. She described why she thinks that. She didn't just say dirt comes from rocks. She described it. She made a full, complete sentences. So she said that there comes from other rocks because other rocks have dirt on them. So they must come from the other rocks where the dirts are. And she says it takes millions and millions of years. And that's a pretty good prediction. May not be right, but it's a very good, educated guess. Let's see. Anybody else would like to share? One more person? Oh, where do you think they come from?
Oh.
So you didn't answer my second question. That's fine. How many years do you take to form?
50,000.
So he said a very specific number. He thinks 50,000. Jones, where do you think sedimentary rocks come from? Where do you think that dirt and all of that debris and the particles that Henderson was talking about, where does that come from? You're still thinking, maybe pick someone else that can help you out.
All that sand comes from the bottom of the ocean.
From the bottom of the ocean? How did they get there?
Because sometimes people throw sand.
Oh, so maybe someone threw it there?
No, it was there.
The air?
No, it was there.
It was there. Had to come from the. JJ is crying out of his seat to try and answer this. Okay, JJ, what's your answer?
I think it came from I agree with them that it came from the ocean because a long time ago I think Florida used to be covered underwater, and I think that's where the rocks came from.
So Florida used to be covered with water. The water has gone away into the oceans, and out comes Florida, and that's what formed the rocks. Very well could be. I'm gonna put our hands down. We gotta keep moving, guys. So all of your predictions, I went around, I read some. They're pretty good, and I'm gonna read more about them tomorrow too. So this is the answer here. So it takes millions, happens over hundreds and thousands to millions of years. So some sedimentary rocks are formed in hundreds of thousands of years, okay? Some might take 100-year-old, and some might take 1,000-year-old. When we were watching Bill Nye, what did he say the difference might be if it waited a million years and not just 100 or 1,000? Anyone, do you want to answer this?
Yeah, sure.
So you're going to go back and look? Oh, so you're going back to your Bill Nye notes. Does it have it in those notes?
Yeah. Oh.
I do like that you're going back and using your resources, but I don't know if it's on there. So what would be the difference? If one rock takes 100 years and one rock takes 1,000,000 years, what would be the difference in
It
rocks?
says soil comes from dirt, which comes from rock.
Soil, yes.
Market.
Okay, choose someone in your group to answer the question for you.
Max.
I think that like the particles will be smaller, like since it's being
Which
crushed
ones would be smaller, the ones that are 100 years old or the 1,000,000-year-old?
millions year old.
So you think the particles would be smaller? What about the
Yeah.
size of the rock?
The size will be like for the new rock from the dust particles, or like
The 100-year-old rock and the 1,000,000-year-old rock, what would be the difference in size?
Oh, the 1,000,000-year-old rock would be smaller.
You think it would be smaller?
Yeah.
Does anybody think differently? Raise your hand if you think the 1,000,000-year-old rock would be bigger. Raise your hand if you think the 100-year-old rock would be bigger. Let's try that again. 100-year-old rock or 1,000,000-year-old rock? 100-year-old rock is bigger? Raise your hand. 100-year-old rock is bigger. Put your hands down. 1,000,000-year-old rock is bigger. Okay, why would you say it's bigger?
Because it took up like millions of years to build up all the rock that is huge.
Yeah, think about a person. Think about a person. If a person is 2 years old, how big are they?
Not
How tall are they?
Like
Not that
3
big.
feet tall.
Couple feet, yeah. And if you're 20 years old, how tall are you?
Tall.
Like 6'3".
You're a little bit bigger, right? You're a little bit bigger. Okay, and all of these sand and all of these particles, they come in 3 different ways. This is a preview for our next lesson, which would be wind, water, and ice because of erosion. The wind will carry the sediment and take it and put it into the ocean. It might take it and put it into a plot of land. Water can move things, right? Think about a canoe going down the river. Does the canoe move?
Yeah.
Yeah, and sometimes it can just float and go down, and that's because the flow of the water is able to take it somewhere. And then ice. We don't get snow here in Florida, but when it does snow, it captures all of that dirt, and then when it is clear, it can also have the ability to move things. Yes. Do you have a question? Yes, go ahead.
How did they make water?
The water cycle. You remember the water cycle, how it goes from the ocean to the clouds versus precipitation? It has a whole cycle. Yep, we'll get into that. Lazaro, last question.
The water breaks down the rocks to make it sand.
The water breaks down the rocks to make it sand? Very well might. I'm not really exactly a professional on that, but yes. Okay, so I want us to think about this. Remember how we talked about the layers and the sedimentary rocks?
Yeah.
Which layer do you think is older? Do we think, if you think on a rock, you hold the rock up, the layers at the bottom of the rock are older, or the layers at the top of the rock are older? Okay? Sit down on the floor if you think it's the bottom layer that's older. Stand up if you think that it's the older one. The top layer is older. Okay, I want someone on the floor to tell me why they think the bottom layers are older.
Wait.
Let's see here. Anderson? Go ahead, Anderson.
I think the bottom layer is older because when the top layer just might have arrived in like 100 years ago, but when the bottom layer might have arrived 1,000 years ago.
Perfect. So that's exactly right. When we think of layers, he says that the top layer might have just arrived, right? But the other layer might have been there for a long, long, long time. Because when we think of things, we stack up stacks of paper. Okay, I have paper here and I have a paper here. Which paper comes first?
The bottom.
The bottom one, right? So I see that, I can see. And now which one comes first? One's older, I'm sorry, I said first, but I meant older. Which one is older? the one at the bottom one was sitting there longer. Okay, go ahead and sit back into your seat. Okay, so I'm gonna give us a description. We're gonna make a rock, okay? We're actually going to be making a rock. So before we make a rock, we gotta think about where a rock comes from. And I think since we're in Florida, and I think it's like a nice thing to do, I wanna think about the bottom of a shallow ocean, okay? You can also think about a lake, something like that. What kind of things are in a shallow ocean or a lake? I'm looking for my stylus. I lost my stylus.
Let's use your finger, I'll look for it.
Okay, I think it's over here somewhere. It's right here. Bottom of a shallow ocean. Let's see. Brennan, what are some things that are found in the ocean? Huh? Fish? Fish. Brennan, pick someone to answer the next one.
Seashells.
Seashells? Can you pick someone? 1, 2, 3. Gerard?
Sand.
Sand? Gerard, pick someone? Seaweed? Go ahead, pick someone. Rocks, for sure, rocks. Or pebbles. Stephanie, pick someone. Alexa?
Jellyfish.
Jellyfish, maybe? So, when I talked about sedimentary rocks, go ahead and put your hands down. When I talked about sedimentary rocks, I talked about how they can take on the form of what's around them, right? So if we have sedimentary rocks and we need time, and what else do we need? We need time and something else to make sedimentary rocks. What else do we need?
Pressure.
Let's all do it. Pressure. Pressure. Time and pressure. And that pressure can trap a lot of things, right? If a fish died and then was sitting on the floor and it created a sedimentary rock, what will that fish look like when I take out that rock? Look like bones? And what do we call those? Fossils. Thank you, Centron. It would be fossils. So that's where we get all these fossils. So today when we make our sedimentary rocks, we're going to try and put some elements that are found in the bottom of an ocean into our rocks. So we're going to have sand. We're going to have glue because it represents time. We're going to have a little bit of rocks to go into the bottom of it. And I don't have any fossils or any fish bones or anything like that. So we're going to have to skip that part, unfortunately.
Wait, Miss Schmidt.
Yes.
A couple times ago, at the back of a bush, we found like a little shell fossil.
Oh, you found a shell fossil before.
Uh-huh.
Okay. So our rocks are going to fossilize into our sediment. Okay. So let's do that. All right. So extra out here. Okay. So the supplies and material that you are going to need. You're going to need a liquid glue. Captain, to make sure that you're checking for these things. Liquid glue. You're going to need sand. Miss Matas is in charge of sand, okay? We're all going to do this at the same time. You're going to need a little bit of water. Well, and then, we're not probably good because we might not use the water right now. Shells, which we have a little bit of shells. Rocks or pebbles, which Miss Matas and I have. We're going to be distributing these out as a group. And then a milk carton or a plastic cup. Everybody lift up your milk carton that we have, okay? The milk carton that you have. So we all have our supplies?
Yep.
All right. We have everything that we need. The first thing you're going to do is write your name at the bottom of the milk carton. Then we are going to, we're not done, we have to read our procedures first. Before we do anything, we have to read our procedures. A good scientist always looks at everything first and then goes back and does this. So the very first thing we're going to do is write your names at the bottom of the milk carton. Then we're going to add sand as our first layer. It's going to be a very thin layer of sand. Then we're going to add a layer of glue on top of that sand. It's not going to be a whole lot of glue. It's not gonna be a whole lot of glue because we don't want it to be too thick because it'll take longer to dry and it'll take longer for your sedimentary rock to form. And then we're gonna add shells and rocks to our glue. Then we're gonna add another layer of sand and we're gonna add some pressure, right? How are we gonna add pressure? Lazaro? Pushing it with our hands. That's pressure, right? I'm putting pressure on this. We can definitely do it that way. And then you're just gonna repeat it. Add a layer of glue and add some rocks and then add some sand on top. So you're gonna need sand at the bottom and sand at the top. Okay? Then we're gonna put it outside for it to sun. So what's the very first thing that we're doing? What is the very first thing that we're doing? Zaire?
We are writing our names at the bottom of the cup.
All right, go ahead and do that now. Go ahead and go back to your desk there because you're gonna have to be in your group. While you're doing that, Ms. Montes and I are going to go around and sprinkle a little bit of sand when you're done with that. So when you're done, just hold up your milk carton and we'll know to go over there with some sand. Okay. When I give you your sand in your cup, are we gonna shake around our sand?
No.
No. Are we going to dump it on the ground?
No.
No. How are we gonna hold it? We're gonna hold it very straight, up and down. We're gonna be very careful with it, right? Because if you dump it all out on the ground, you're not gonna have a sedimentary rock, and Miss Montes is gonna have a big mess to clean up, and that will not be fun, okay? You're welcome. And you are your group leader, so you can actually take your glue and do a thin layer. I got a little sand on there, I'm sorry.
Can I take all my glue?
No. You gotta stay safe with COVID, you know. The fact that we even get to do like hands-on activities, that's like a privilege. I'm gonna give group leaders the sand first, that way they can start pouring the glue in. Okay, and you wanna make a very thin layer. Don't make a super big layer of glue. Just enough to cover it.
Can you do it in my
And look how quiet everybody's being. I don't know if I've ever heard them be this quiet and spotted. I gotta get more sand. Okay, I'll be right back.
I got it. I got
Thank you.
it. You want to come ready?
Yes.
You have? Okay. You did it already? You did it all?
Who else needs sand?
Okay, put it in there.
You don't need everything?
In there. Then you can go.
And there should be 2 bottles in each group, so I'm gonna go around and also help. You need to help. You need to pour the glue for your other teammates, okay? You need to do it for them. Because you're the only one that's going to be, it needs to cover the whole thing. Because the sediment has to stick to something, right? The fossils and all of that has to stick. You gotta cover it even more. Okay. Go ahead and do that for the next people. I'll start with that. And we might only be able to do 1 layer, depending on how much time we have. Kind of mix it around, see if we can get 1 layer out of that.
Which should I use?
We're gonna just tilt it. Just want to tilt it a little bit. You wanna see it? You can hold it.
Okay.
It looks like an ant nest.
Oh, the that's almost out.
Maybe. There you go.
Okay. Do you have any paper towels to clean the? Oh no.
Nevaeh, are you filling your others with glue?
I just finished them both.
So weird.
I did this.
We'll get one layer of glue. Yes. Yes, go ahead. Thank you for asking. Take a lot of concentration. Did we notice that we're using even more than Sanderson, it needs to be like a whole thing covered. That we're using milk cartons that have already been used for, no, a whole layer. Like, Denaya, can you go look at Denaya's? One whole layer would be like, we're using milk cartons. What do we when we're not using supplies, we're reusing supplies? What do we call that? Think back to my old lessons. What do we call that? Jones? Reuse, I'm reusing it. There's a different word I'm looking for. Hezekiah?
Renewable resources.
No, renewable resources can never run out. I can run out of milk cartons, can't I? Sit down, I'm not gonna call people that are out of their seats. Who needs glue?
I don't remember.
You don't remember, that's okay. Gerard, do you remember? Recycling is an example. They're almost done. Okay. Yinwal? No. Alexa, we're gonna go around while we're thinking about that. Miss Matos and I are going to go around and we're gonna put our rocks that we talked about, right? Putting our rocks and shells into your thing. And then we're gonna add another layer of sand and then we're going to apply pressure. So once you got your second layer of sand, we're gonna apply pressure. Denaya, do you have the answer to my question? What did you think it is? What is it called?
She said conservation.
Conservation. That's exactly right. When we're not using our resources. Good job, Denaya. Remember, that's a star for your team. And I'm only going to drop a few in here. We got a whole class. And if you had sticks, if you had sand, if you have this, it kind of just all joins together, right? Just like a regular rock would. Kind of all just comes together. So if we're reusing things, we're conserving. This is, yes, we can all thank Max and Alex and Gerard for helping me this morning. I picked them up from daycare. And what did they do? We went to daycare and we picked up some of these rocks for us for our project. We went outside searching for them this morning before school even started. So their school day started a little bit before. We need glue. More glue. Has to stick.
Stop pointing that at me.
Whole layer. You can do this one.
What's the whole layer?
Whole layer has to cover the whole thing. Make sure it kind of like sticks to the bottom. Do you guys all have rocks?
No.
Okay, I'm gonna start passing out sand on Miss Matos because
I don't know, bro. It's sinking.
why would we put sand on top of it? That's a good question because Alexa said sand again. Why would we put sand on top of it? Centron? Because it needs pressure. Yes, I agree with that. Yes. Good job. And Alexa, I like that. I didn't call on you, but you said, oh, you're celebrating the fact that you still have the right answer. And I like that. So good job, Alexa. You need more glue.
One finger.
Anderson, he needs more glue. I'll put. So do you, Anderson, maybe. Yeah, he needs more glue. Oh, I'm sorry. No, you're fine.
If you need rocks, please raise your hand. Why not?
Yeah, I need something to stick to, right? But yours too?
Cheers.
They're not melting.
Did you get sand? Second layer sand?
I need.
Yes.
You haven't.
Oh, I don't even want to know about that, girl. A person that put Gorilla Glue in their hair?
Oh,
That seems, this is why you have to be careful with our rocks and handle them.
So do we?
Any more snacks? We're just putting a second layer of sand on. Most of them, yeah. Okay, so those of you that do have their second layer of sand on top of your glue, you need to now apply pressure. How are we going to do that? We have to actually take our hands and apply the pressure with our energy from our hands. So go ahead and press down on your sand. Because there should be 2 layers of sand. If you're dipping your hand into glue, you're probably not doing the right thing, right? There's a second layer of sand that you can press down on. So you're not yet. Well, that's not good now.
I only feel blue.
Okay. And those of you that are done with that, because I know that some of us are done, we finished our procedures.
I think I put too much glue.
And after you are done with this, we have 15 minutes before we go to PE. I need everybody's attention. 5, 4, 3, 2, and 1. You're going to be writing in your journals, explain why fossils are found inside sedimentary rocks. Your fossils are going to be the rocks that we put inside of our rocks, right? Seashells can be found. A lot of us, when we went looking yesterday at recess, we found fossilized shells. Why do you think that is? Can you explain why? And I want you to tell me out loud. I want you to write it in your journals, okay? And then I also want you to draw and label your sedimentary rock. So what I would want is for you to draw a layer of sand, a layer of glue, adding the pebbles and labeling all of these things, and another layer of sand. And give me a good description in details and drawing what your rock might look like. Does there anybody have any questions about that? I already see a few people starting to work on that, so I really, really, really appreciate it.
Oh my god. Look at my fingers. It looks like sandy 1, sandy 2, sandy